Welcome to Precalculus Algebra, finding the equations of hyperbolas. So for example, let's say we wanted to find an equation for the hyperbola with foci positive negative 6, 0, and vertices positive negative 2, 0. So first of all, if we just graph what we have going on here, so the foci, let's say here's a focus at 6, and here's another focus at negative 6, and then we have vertices at 2 and negative 2. So 2 and negative 2. So I can see that the transverse axis, that is the axis that connects the foci, is horizontal. Now we know that the center of the hyperbola lies on the transverse axis between the vertices. So the center of the hyperbola is right here, that is at the origin. So our our hyperbola is opening towards the foci, so it looks like this. Remember, it goes through the vertices. So it's going to look like that. It's one branch, and then the other branch is going to be symmetrically on the other side, looking like that. So the equation of a hyperbola centered at the origin, oriented with the transverse axis horizontally, that equation would be x squared over a squared minus y squared over b squared is equal to 1. And we derived that, or we found that last time in our previous video, the graphs of hyperbolas. So what we have to do, we're looking for the equation of the hyperbola, right? So we've got to find a and b. Now the vertices, the first coordinate here, that's our a. So a is equal to 2 in this case. So right now we have x squared over 4, take away y squared over b squared, right, is equal to 1. We've got to find our b squared here. Now, of course, this is a, but the foci, that number there is c. So remember, the foci has coordinates positive negative c 0, whereas the vertices was positive negative a comma 0. So c is equal to 6. Let's write that down. So c is 6 and a is 2. And of course, if you know a and c, you can find b. And the reason is because b squared is equal to c squared take away a squared for a hyperbola. So in this case, b squared is equal to 36, take away 4. That is 32. And you've got your b squared. It's 32. And that would be the equation for this hyperbola over there. Now, we weren't asked to graph, but it's nice to have a little graph just to orient yourself so that you can find the equation that serves as the template. All right, let's take another example like that. So let's find an equation for, whoop, that shouldn't say parabola, that should say hyperbola. Let's go and write that in. Hyperbola. So find an equation for the hyperbola with vertices 0, positive negative 5, and passing through the point 7, negative 10. So this point is on our hyperbola. So the vertices, notice that they are along the they're on the y-axis, right? So positive 5 maybe right here, and negative 5 would be, let's say, right there. And so the transverse axis is oriented vertically. And once again, we see that the center would be at the origin due to the symmetry of the location of the vertices. So the center would be right here, and our hyperbola opens like this, opening up, and that's the top branch, and this would be the bottom branch. Now we're also given that the hyperbola goes through the point 7, negative 10. So if this is 7, then negative 10 is like right here. So we want that hyperbola, right? That goes through these points as vertices, and then goes through that point 7, negative 10. So that's how we interpret this information. Now, based upon the fact that the transverse axis is vertical and the center is at the origin, we have the following equation as our template. That is y squared over a squared, take away x squared over b squared, is equal to 1. Now, just like before, the vertices tell you what a is, right? So the vertices have coordinates 0, positive negative a. So that number here is our a. So a is equal to 5, and we've got to find our b squared. So we have y squared over a squared is 25. Take away x squared over, now we're looking for b squared, and the way we're going to do that is we're going to make use of the fact that the point 7, negative 10 is on the hyperbola, so it satisfies this equation. So I'm going to plug in negative 10 for y and 7 for x, and I'm going to solve that equation for b. So I've got negative 10 squared, right? Let's try it like this. Negative 10 squared over 25 minus x squared, plugging in 7 for x. So it's going to be minus 7 squared over b squared. That's equal to 1. So we've got 100 over 25 minus 49 over b squared is equal to 1. So 100 over 25 is 4. Take away 49 over b squared. It's equal to 1. So if we then subtract 1 from both sides and add 49 over b squared to both sides, we're looking at 3 is equal to 49 over b squared. So our b squared is equal to 49 over 3. So we take that b squared and we substitute it right there. So our equation is going to be y squared over 25, take away x squared over 49 thirds is equal to 1. So that would be our answer. Now you can leave it in this form. This would be standard form for this hyperbola, or you can multiply top and bottom by 3 here, and you'll have 3x squared over 49. Either way is okay. All right, until next time.